This is an important problem related to star-delta conversion. This is a simple problem, and by understanding this problem clearly, we can do almost all star-delta conversions. Here the question is to find the equivalent resistance between A and B. Three terminals are shown, A, B and C, and we have to find the equivalent resistance between A and B. Here we can see that this is a complex network consists of different star and delta connections together. And it is given the value of each resistor is equal to 1 ohm. Here there are about 1, 2, 3, 4, 5, 6, 7, 8, 9 resistors that are connected in star and delta. Firstly, we have to simplify the circuit by using the star delta equations. Let's start from the center of the circuit. By looking into the circuit, we can see that the center portion of the circuit is a delta connected one. That is, this resistance, this resistance, this resistance, three of them are connected in delta configuration. Therefore, firstly, we have to convert this delta configuration into an equivalent star configuration. And from equations, we know that in order to convert a delta connection into star connection, we have to understand the equations. RA is equal to R1 R3 by R1 plus R2 plus R3. RB is equal to R1 R2 by R1 plus R2 plus R3 and similar. Therefore, in order to let the equivalent star resistance be RA, RB and RC, then I can write RA is equal to all resistors are 1. Therefore, I can represent RA is equal to RB is equal to RA is equal to 1 into 1 by 1 plus 1 plus 1. 1 plus 1, that is equal to 1 by 3, and it is also equivalent to RB and RC. RB and RC, it is equivalent to RB and RC. All of them are equal to 1 by 3 because all the resistors are equal. That is 1 by 3. Then I can reduce the corresponding network into, this is a point, this is outer delta, this is outermost delta, this is a outermost delta, this is a point, this is a B point, and the equivalent resistance reduced to equivalent resistance will reduce to this circuit. That is, the outer delta is there and the centermost delta portion is converted into equivalent star, and the 3 star arms are connected into series with the 3 resistors. Therefore, this is the circuit. And again, by looking into the circuit, I can see that these 2 resistors are connected in series, these 2 are connected in series, and these 2 are connected in series. And value of these are, this is 1 and this is 1 by 3. Therefore, here is a series combination of 1 and 1 by 3. We know that when 2 resistors are connected in series, equivalent resistance R is equal to R1 plus R2. Therefore, I can redraw this circuit into simplified form as, this is my A point, this is outermost delta, this is outermost delta, and this is outermost delta, and the corresponding resistance equivalents are represented by a single resistance, and the value of that single resistance R effective is given by 1 plus 1 by 3, and that is equal to 4 by 3. Plus 1 by 3 is equal to 4 by 3. The value of this resistance is 4 by 3 and this is 1. Now I can see from this equation that this circuit consists of, this is a B point and this is a C point. This circuit is an equivalent of an outer delta and an inner star connected. My next step is to convert the inner star connected network into a delta connected network. Then I can redraw the circuit as, this is my A point, this is my outer delta, this is A, this is B and this is C, and I have to convert this star network into an equivalent delta network. That the circuit will look like this. Circuit will look like this. This is the equivalent corresponding delta of the star consisting of all the resistors 4 by 3. Therefore, in order to consider the effective resistance, in order to convert the effective resistance, this is the effective resistance, we can know R effective is equal to the corresponding star to delta conversion equations. We can know that it is equal to RARB plus RBRC plus RCRA, the whole divided by corresponding resistance opposite to that of the corresponding delta arm, that is equal to, we know that all the resistors are 4 by 3, therefore it is equal to 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3, the all divided by 4 by 3, and that is equivalent to that is equivalent to 4 ohm. That resistance is equivalent to 4 ohm. Therefore, the circuit has reduced to an equivalent connection of 1 ohm, 1 ohm, 1 ohm. This is 4, 4, 4. And from this circuit, I can see that the 1 ohm resistance branch and 4 ohm resistance branch is in parallel. This 1 ohm resistance and 4 ohm is in parallel. This 1 ohm and this 4 ohm is in parallel. Therefore, I can simplify the circuit by using simple parallel reduction. The equivalent circuit will get reduced to a single delta consisting of 3 resistors. That is, this network is A, this is B, and this is C, and this is equivalence of 1 and 4 in parallel. This is equivalence of 1 and 4 in parallel, and this is equivalence of 1 and 4 in parallel. Therefore, I can represent R equivalent is equal to, so 1 by R equivalent is equal to 1 by 1 plus 1 by 4, and that is equal to 4 by, that is equal to 5 by 4, and therefore R equivalent is equal to 4 by 5 ohm. Therefore, each of these amps is equal to 4 by 5, 4 by 5, 4 by 5. Next, I have to determine the equivalent resistance between point A and B. By looking into the circuit, I can see that in between A and B, there is a resistance 4 by 5 connected, and a series arm of 4 by 5 and 4 by 5 is connected. Therefore, equivalent resistance between RAB is given by 4 by 5 in parallel with 4 by 5 plus 4 by 5, and that is equal to 0.533 ohm. Therefore, the equivalent resistance between RAB between A and B is 0.533 ohm. Therefore, by going through the question again, I have simply reduced this circuit into a simple delta connection network, and from that I can represent the equivalent resistance as 0.533 ohm. This is very simple and basic problem solving method by using star delta conversion technique. We have to carefully understand the different equations that have been used so that we can simply solve the problem. Thank you.